Good afternoon and welcome to Webinar Wednesday. We're excited to have over 560 registered attendees for today's webinar, which is eligible for 1 credit from the ACI. Let's get started by giving one lucky attendee a Webinar Wednesday lunch bag for answering this trivia question. July is National Hot Dog Month. What is the most popular hot dog topping? Answer now using the questions feature on your dashboard. While you're answering, I want to invite everyone to save the date for our fall MD Expo, which will be taking place at the Hilton Baltimore Inner Harbor from October the 17th to the 19th. We look forward to you joining us for 3 days of learning, networking, and the latest advances in medical technology, products, and services. Registration is now open, and more details can be found at mdexposhow.com. Okay, and let's see who the winner of our Webinar Wednesday lunch bag is, and it is Jake Narby. Congratulations, Jake. Of course, the correct answer is mustard. Webinar Wednesday would like to thank our sponsor, Rigel Medical. Rigel Medical is a leading manufacturer of biomedical test equipment, including electrical safety analyzers, vital sign simulators, infusion pump analyzers, electrical surgical analyzers, and Medibase asset management software. For more information, visit rigelmedical.com/USA. Our presenter today is Brittany Schmeich, National Business Development Manager at Rigel Medical. Brittany, you may begin whenever you're ready.
Hi guys, thanks so much for joining me today. This is Brittany Schmidtke with Rigel Medical, usually coming from the sunny state of Florida, but right now we are actually having some very serious thundering and lightning, so I apologize if you can hear that in the background. So today we're going to be talking about electrical safety testing to some of the new standards and some of them that have been revised recently. Let's see. Okay, so we're going to look at the background and kind of why they put these guidelines in place for you guys. We'll look at the different standards, codes, classifications, and how they vary between guideline to guideline. We'll look at the actual testing that you guys do and some things to take in consideration to make sure that you are in line with those guidelines. And then I'll do a quick summary and closing comments, and we will then open it up for a question and answer session. So any questions that you have throughout the presentation, feel free just to jot down, and we will definitely leave some time at the end to get those answered for you. Okay, so electrical safety testing. Why do we do it? Why is it so important? So the object is to confirm that the medical equipment is electrically safe to be used in a healthcare environment. So we're looking out for patient safety, or MOPP, which stands for Means of Patient Protection, and then also the operator safety, or the MOOP, which would stand for the Means of Operator Protection. So in the 1970s, there was quite a bit of panic that swept the nation in regards to electrical shock that people were starting to hear was happening in patients in the hospital. They had some studies that were starting to come out that was showing that microshocks could actually introduce ventricular fibrillation in patients that were in the hospital. So what really started this massive panic attack across the nation was an article. It was written by a guy named Ralph Nader, and he published it in the Ladies' Home Journal magazine. So if you've never heard of him, Ralph Nader is an American. He's a political activist. He's an author. He's a worldwide lecturer. I believe he's also an attorney. But basically he's known for his involvement in protecting the consumer and also getting really involved in government reform. So basically this article quoted a handful of experts estimating that there's over 5,000 undetected electrocutions in hospitals every single year. He also went on to express the serious concern of patient safety, Also the serious concern of the safety of the workers operating with the device. So this did cause quite a stir across the nation, but the good thing is that it did shed light on the situation, which initiated the need for the more strict electrical safety guidelines that we adhere to now. Okay, so back to the basics. Electrical current is defined as the rate at which charge flows through a surface. So as you know, the charge can be negatively charged or positively charged, and the electrical current will obviously be flowing the path of least resistance, just like water does. So if you pour water downhill, it takes several paths. But as soon as that particular path becomes somewhat crowded, the water is going to open up a new branch. So this is kind of how electricity current works as well. So with that theory, if you touch equipment that is short-circuited, even if it's grounded, some current is still going to pass through you, where you get that little bit of a tingling feeling. So this is basically because a few of those electrons, they find your body as an unoccupied exit that they can get out easier and quicker. So electrical current that is quote unquote functional actually plays a pretty integral part in diagnosing the patient, in treating the patient, and even in just monitoring them. For example, if someone's paralyzed, let's say due to injury, they'll use low energy electrical pulses that artificially generate body movements in the central nervous system. So these pulses can aid in basically generating the muscle contractions, that can help to improve functions like grasping or walking or standing. So pretty interesting there. But however, on the flip side, it can obviously harm the patient or the caregiver in several different ways if something isn't functioning properly with the unit. So this is where you guys step in to ensure the patient or doctor is not exposed to any unsafe current. Okay, so the diagram you're looking at here was created by a guy, Charles Dalziel, and he was a professor of electrical engineering at UC Berkeley, and he primarily was studying the effects of electricity, both on animals and in humans. You might have heard of it. He wrote the book, The Effects of Electric Shock on Man. And in that book, he basically explained the effects of different amounts of electricity on humans. And I believe in the next slide, we'll get into that a little deeper. So basically, you can see in this graph, he was looking at the frequency response within the body at different hertz. So it's standard to use a 1K ohm resistor here to actually simulate the resistance within the human body. And you can see in the range here on the graph that as the current increases, the body becomes less and less stimulated. Okay, so macro shock is an electrical current that passes through the body when contact is made between skin and the current itself. And this is obviously non-invasively. So basically here you can see the effects it has on the body in both males and females at the different levels of current that that person was exposed to. It's a little bit of a busy page, but we'll walk through it rather quickly. So the least physiological effect someone would see would be at 1 milliamp for a guy and 0.6 milliamps for a girl. At this stage, though, if you felt anything at all, it would be a very, very slight sensation in your body. Most of the time, it's not even detectable, completely unperceivable. But as we move on, the next level is going to be the threshold of perception. So essentially, this is the lowest electrical shock that is normally detected by the human body. Moving on, we're going to get into when you're starting to feel this current going through your body. So you will feel pain, but you'll still have control over your muscles at this level. So this is what they call the let go stage. So even if you're experiencing a lot of pain, you're still able to let go to get rid of the electric shock, to stop it. So the next level is where things start to get pretty dangerous. You're going to be experiencing a lot of pain, but in addition, you lose control of your muscles. Electricians, I know, will often refer to this as being froze to the unit. And that's typically what it looks like. I'm sure you guys have seen pictures and stuff of, people at the top of the telephone poles, and they're literally frozen in place. So this would be the level that they're at that point. So definitely not something you ever want to experience. And even at this stage, things could end up being fatal. But the next level is when it gets very serious and fatality definitely increases. So this is going to be at 90 milliamps for a male and 60 milliamps for a female. So this stage is really when you're going to start to experience severe pain. In addition to that, you've lost almost 100% of your muscle control. It's just gone. So it's possible that you could have also pretty severe burns, both internally and externally. That can obviously cause nerve damage. You could also get some cognitive damage like memory loss, things of that nature. Very, very dangerous. And then finally, at the 500 milliamps, your body goes into complete ventricular fibrillation, and it's pretty much over at that point, unfortunately. Okay, so let's talk a little bit about leakage current. So to put it simply, this is going to be the current that is quote unquote not functional. It's basically the unintentional loss of electric current or of electrons, basically due to any capacitance or any resistance that it's facing. It's obviously going to be flowing from a high to low potential, or downhill, as some people say. So as long as the leakage current stays within the range of the guidelines, it's considered completely safe. However, once that reading falls even just a little bit outside of the range that the guidelines state, that's when it becomes a danger for both the patient and any of the staff. So some of these results, when this actually happens and you're exposed to leakage current, can be anywhere from a tiny zap, which I'm sure all of you guys have experienced. I know I have several times, especially working on these machines. And then obviously other far end of the spectrum would be cardiac arrest. That can occur as well. So for example, excessive touch current could be life-threatening to a patient. I'm trying to think of an example. Say a staff member is touching the equipment with one hand, and then he touches the patient's bed with the other hand. Well, the intensity of the shock is going to depend on how much current is transmitted through the person's body, but it is something that you really don't think about, and I assume a lot of the medical professionals don't think about as well, that could be very potentially dangerous to the patient. And usually the problem with this is it's just, degradation of the components of the device. Just simply by wear and tear, age of the device. Also, I mean, you guys see the defective power strips, power cords, devices where fluids have been spilt on them. So this can all make things potentially dangerous as well. Okay, so now on to the different standards and classifications that you guys and girls have to test to. Let's start with the IEC 60601, or that's the AMI equivalent of the ES 60601. So these are going to be your basic manufacturing standards, I guess that's what you could call them. When we move on to the IEC 6353 and the NFPA 99, these standards are just a little less strict than that of the manufacturing standards. There's basically just a handful of different tests that are not required for you to do, just a little less stringent overall. Good for you guys. And then finally, we have the IEC 61010. This one isn't heard about as much as the others, but basically more for, I would say, lab equipment rather than medical equipment. Okay, let's talk about the different classifications out there. So when it comes to electrical safety testing, a class 1 device is equipment that has protection against electric shock, which is achieved through a means of connecting exposed conductive parts to the protective earth in the fixed wiring of the installation or through the grounded power cord of portable equipment. That was very long-winded definition, but basically just a device that has a ground pin on the power cord is the easiest way to think of it. And so that ground pin is what we really count on to attract any of that leakage current back to ground. So if you look at the back of a medical device, I'm sure you guys all know this, there's the symbol telling you which class of device it is. So the circle that you see right there that just popped up with the ground pin inside of it, that is going to be your class 1 device. Okay, now with a class 2 device, that is the symbol that you guys just saw pop up right now. So we always describe it as class 2 being a, like, quote unquote box inside of a box. So these are also known, you've probably heard them called double insulated devices. So basically the device is more or less in a plastic box. So because of that, there can't be any contact with anything that is conductive. That's making it obviously a lot less dangerous. So we'll look a little bit later at some of the changes that have been made, especially recently in the last few years, on the testing of class 2 devices, because that's where a lot of the changes really took place, especially with the NFPA 99 standards. Okay, so you guys know that when doing electrical safety testing, you're also going to have to attest the applied parts for leakage as well. Some examples of this would be an EKG box where the patient connections would be the leads, a defib box where the patient connections would be the paddles, and it could also be a SpO2 attachment or even an infusion pump, where the connections to the patient would, what you would be testing for leakage there. Okay, so the 60601 standards. We talked a little earlier about these being the manufacturing standards within the industry, and we talked about them being more stringent than some of the others. So 60601 came around in 1976, and basically just to ensure the safety of both the patient and the user of the device. 60601 is also done in single fault conditions such as open earth, just to look at the increase in leakage current at that point. And then I believe it's also done in open neutral, where it's looking at the increase in the leakage current going on there. Once again, you're going to have to attest the applied parts or the patient connections. So one of the big things and big differences that you're going to see in the 60601 standards is that when you're testing applied parts, you have to test each connection individually to ground. Then you have to test each lead to lead individually. And then all of those tests then have to be done in both normal and in single fault conditions. So, I mean, you're looking at a lot of testing time, as I'm sure you can imagine, and a lot of what they've deemed now unnecessary testing. So that's kind of how the 62353 standards came about, basically to make it quicker and easier for you guys to test the devices, especially ones that were already in the field and have been in the field. That's more of a manufacturing standard. So if they made it through manufacturing, they kind of figured that they're pretty good at that point. So with the 62353, there's going to be 3 different versions of this. There's first direct, and then alternative and differential. So first direct, it's basically designed actually to test the same way as the 60601 standards are. Really no differences. The alternative basically says to connect your hot and neutral lines that are coming into the device and look at what the leakage current would be at the low voltages. And then finally differential, which is, as its name states, the differential between your hot and neutral lines. So the 62353 standard, it was never meant to replace the 60601 standards. It's just saying, like we said before, that if the device met the more strict standards while it was in the performing time, is it really necessary that you guys need to test that intensely every single time you do a PM? So it just makes your life as a biomed simpler, while also staying in line with the more stringent 60601 standards. Okay, moving on. Here we have the NFPA 99. I'm sure your favorite. So these are the most recent standards released. They're typically what I believe most of the facilities and most of the ISOs, at least in the United States, will test to. I know it's not used as frequently internationally, but in the States, this is most likely what you guys are testing to, I would imagine. So they are updated every 3 years, and the last revision was 2018. So look to possibly see some changes in 2021. Sorry, I had to do the math real quick. So these guidelines are dictated by law in most states. So the revisions could definitely vary a bit. Okay, here is an excerpt that I won't bore you with. Pretty much just know that chapter 10 is really going to be the most pertinent one to you guys. It's also the most pertinent one to electrical safety testing in general. So there's the takeaway from that busy slide. So a few years back, they started looking at classifications of areas within a facility. So they were basically trying to identify the risk associated within an area. So NFPA 99 requires healthcare facilities to designate patient care rooms throughout their facility. Very creatively named Category 1, Category 2, Category 3, and Category 4. But we're going to look at those a little bit more closely now. So Category 1. So this is going to be associated with carrying the highest amount of risk for either the patient or the staff that's in that area. And this would be areas like your OR, your ER, your intensive care units, etc. Oop, it went backwards on me. Sorry about that. Okay, category 2. So this area is going to be less likely to cause injury for the patients and the staff. And so these would be places like your dialysis room, your inpatient bedrooms, or your simple procedural room. Okay, category 3. So this is an area where it's not very likely to cause injury to anyone. So examples of this would be your basic exam room or even a dental office would be category 3. And last but not least, category 4. So this area has the least likely chance that anything in terms of electrical injury could go wrong. Think a lab, a waiting room, or even a morgue. Not a lot going on in there. Okay, so this is what we spoke of earlier in terms of class 2 devices. Basically, the NFPA 99, says that double insulated devices do not need to be tested anymore. One less thing for you guys to have to worry about. So when we're looking at fixed equipment in a facility, so fixed equipment is permanently hardwired directly into the facility itself. So that actually needs to be tested prior to it even being installed. So this is primarily where you'll see this equipment would be the OR. And these requirements say that the leakage should not exceed 10 microamps. Okay, so the NFPA also looked at portable medical equipment, particularly in the hospitals. And they decided that these devices can be moved from location to location, from room to room, from OR to OR. You get the gist there. And let's just dive into some of the good stuff. So I'll primarily be focusing on NFPA 99 since that's the most widely used in the facilities and in the ISOs over here. So we'll be doing some comparisons with some of the other standards as well and kind of take a look at the thought processes behind the changes that were made, particularly to NFPA 99. Okay, so let's take a look at ground resistance as that's what they want you to test first. Makes sense. So to do this, you're just going to take your test lead, attach the alligator clip, make sure it's an enclosed connective surface on the device under test. And then you're going to take the plug and plug that into the DUT socket on your safety analyzer. And that would be how you get your ground resistance. Very easy. And you just got to make sure that you have a good solid connection there. You'll get some bad readings. So here you can just a quick visual of the actual setup of the test. You see the device under test plugged into the back of the safety analyzer. And then you can see there the alligator clip attached to the front of the device. Okay, this slide's a little bit busy, but basically it's just saying that the NFPA 99 states that the resistance level you measure must be less than 5 ohms. And it also states that if the device that you're testing has a detachable cord, you really need to wiggle it around some at both ends, just to make sure there aren't any loose connections there that could potentially affect the readings. So here is an example of a quick comparison. Like we just said, in FPA 99, you need a reading of less than 0.5 ohms. And the 60601, the stricter requirement of less than 0.3 ohms. So just a little bit of a variance there that you would expect. Okay, moving on to touch current or leakage current, as I believe it's called more today. But this is the current that's flowing from the enclosure of the device that's going to be accessible to either the patient or the operator of the unit. Obviously, this wouldn't occur until one of them actually came into contact with the enclosure, but and this is typically done just by connecting the safety analyzer to a solid ground on the device under test. So before the latest revision in 2018, you used to have to test your touch leakage in 4 conditions. So that was ground closed and power off, ground closed and power on, ground open and power off, ground open and power on. However, after that revision, it's actually only required to test the last 2 with the ground open. And so the thought process behind this was, if the unit is safe within a single fault condition, it would definitely be safe in normal operating conditions. So another kind of busy slide. So basically, this is just an excerpt from the NFPA 99 standards regarding your fixed equipment. So that equipment that's hardwired directly into the facility. And you can see here that the reading must be less than 10 milliamps, and that's AC or DC, with all of the grounds lifted. And I've scratched out the portion at the end that was changed in the 2018 revisions. So with that change, portable equipment, the reading should not exceed 500 microamps with the ground wire disconnected. And so that just makes you guys life a little bit easier now that they've cut out some of those tests as well. So this is a change that, I skipped a slide, I'm sorry. Sorry, I hope I'm not getting you guys dizzy. Okay, so jumping a little bit more into the actual test procedure, we've talked about regular leakage current as well as lead leakage current. So this is where the real time saver comes into play with both the NFPA 99 and the 62353 standards. So remember we talked about how in 60601 each lead had to be tested separately, as well as lead to lead separately. And then those had to be tested in both conditions. So the good thing about the new standards is you're going to just tie all of the leads together and test them as one. So with that, the allowable range is just supposed to be less than 500 microamps, ground wire open, and 100 microamps with the ground wire closed. So that cuts out a lot of time and a lot of unnecessary steps. Okay, so here's the change that happened in the 2015 revision. They said that no testing was needed for equipment with no exposed conductive surfaces, and undergrounded plastic encased devices intended for use in the patient vicinity should only be visually inspected for damage and to verify that it is labeled as double insulated. So no more testing of class 2 devices, basically. So here are some more of the changes for the non-patient care related equipment. So it basically states non-patient care related equipment, facility or patient owned, shall be visually inspected by a staff or personnel. This would be like your tablets or if you had a computer in there, things of that nature. And as long as everything looks good and it's intact, it's safe for use in the patient care areas. So that's a good thing. I knew they used to have to test even if you had a computer in there. And patients do not like having to live without their tablets and computers. Okay, so some more changes. Let's see. Okay, so this is actually the basics of an electrical safety PM. Let me start off by saying that we're going to be going through a usual PM process. However, I am in no way telling you that this is how it has to be done. Every facility is different. Every facility has different rules, different regulations that you guys have to follow. So just be sure to check with your supervisor to see what you need to be doing in your particular facility. So you're obviously going to start with the usual visual inspection. Just be sure there's nothing obvious to the naked eye that could affect the safety of the unit. And then you'll dive into testing. And once again, remember that every manufacturer will require different methods of testing as well. So make sure you follow that particular company's manual. So you'll start by testing the line cord, flexing it at both ends, making sure that nothing's out of place that could possibly affect your readings. Then you'd go into your ground continuity, then into your leakage currents. And keep in mind too, if the device has a power switch on, it needs to be tested in both the on and off positions. So that's pretty much the same slide. Okay, so here is a quick visual. If my computer wants to work with me. Oh no. Let's see if we can try this again. Previous. Yeah, it's not popping up in my sheet. I apologize. But we do have some quick demonstrations that you can find on YouTube with different safety analyzers. And that's, you know, for all makes and models. I'm not sure what my computer is doing right now. So basically, this is a test sheet that you're going to need at the end of the testing. So this can be captured by you manually, or it can be captured by the safety analyzer if they have the capacity to do that. So basically just pass fail on the visual inspection, the ground resistance leakage current, and lead leakage current, and you're all set. Pretty basic. So you can get a copy of the NFPA 99 booklet. I think it's available on their website. It's very detailed, very informative. If you were interested in that, I do believe that they have both hard copies and electronic copies available. So here at Regal, we also have several free guides that are available to you. This one being relevant to the topic today on testing to 62353 standards. And they're about pocket size, so, you know, easy to throw in your lab coat or whatever, should you need it or need something to reference. So I'd be happy to send you guys them. If you want to drop me an email, I can get as many or whichever various ones that you want. I believe you can now also download them online. from our website, just rigomedical.com. And here's some brochures on the different electrical safety analyzers that we have. I'd be happy to send one of those to you as well if you would like. And here is my contact information. So any questions, concerns, needs at all, please don't hesitate to email me, or that is actually my cell phone. So I have it even when I'm traveling. So yeah, just give me a call if there's anything at all that you need. So thank you guys, and I guess we're going to open it up for questions.
Great. Thank you so much, Brittany. Yeah, we have got a few questions that have come in. The first one is, what is the difference between a Class 1 and Class 2 device?
So like I stated previously, Class 2 is the box inside of a box. So there's really not going to be any potential of danger there. Everything is enclosed, and it doesn't need to be tested, at least in FPA 99 standards anymore. Just Class 1 does.
Okay. What about a device that has a plastic enclosure but has a ground pin?
Ooh, so this is where it can get a little tricky, particular if you're looking at like, there's some infusion pumps and even some monitors that look like they're the box inside of a box, but they do have a ground pin. So our philosophy always is, if it has a ground pin, it needs to be tested.
Okay. Are there electrical safety devices that have universal output?
Sure, yeah, actually, both of our safe tests have universal output, and I'm sure, you know, all of the other companies out there would at least have one option available for that.
Okay, just a few quick questions as well. The Joint Commission references NFPA 99 for California. Is this a new standard compliant?
Yes, yes, it is compliant. Absolutely.
Okay. And again, about the NFPA 99 2015, how does this affect electrical safety inspection frequency?
So the NFPA 99 really doesn't state in terms of frequency of PMs. That's more mandated by the manufacturers or your hospitals even. The NFPA 99 is basically just telling you when you test it, how to do it. So that's something you would need to refer to the manufacturer of the device to see what it is that they recommend you doing.
Okay, and is electrical safety testing required for scheduled preventative maintenance?
Yes, absolutely. Yes.
Okay. Right, here we go. How about testing electrical safety on 220 volt devices? Is there test equipment for those devices, lasers, C-arms, etc.?
Yes, there are, and there are across the board. If you want to shoot me an email, I can get any information over to you that you would like, but they are available.
Okay, righty-ho. What class of equipment is the man in a box?
A man in the box. I'm not sure what he or she is referencing to, unless it would be floating possibly, which would be Class 1. If that's what he's referring to by man in a box, it would be a Class 1.
Okay, righty-ho. Are there requirements in NFP 99 that are not covered by IEC 60601? You mentioned 60601 is stricter, so if you adhere to 60601, can you ignore NFP 99?
Yeah, absolutely. I mean, the NFPA 99 was basically just discovered like the 62353 was, and that was just basically to cut out a lot of unnecessary testing. I mean, it makes sense that when something's being manufactured, it most definitely needs to go through stricter standards. But they're thinking if it made it through the manufacturing and a simple PM, everything is turning up okay, then it's probably okay. So 60601 will meet the requirements of everything. It is definitely the most stringent by far.
Okay, and what's the limits for the leakage current and the limit for earth resistance?
Ooh, off the top of my head, leakage current, I believe is 300 milliamps, and ground leakage. I'm not sure about that. Let me double check that for you. I can't remember right off the top of my head, but I can get that sent to you for sure.
Okay, well, I'll send you the attendees'
Okay,
questions
great.
anyway afterwards, so
Great.
you can always expand on that. I have actually got a question here. Where can we get the test sheets you displayed with standards and values?
Okay, so there's not really one that I know of available. We kind of made up a mock one that we can definitely send to you to use. And that's what, most of our facilities use when they're using a simple Safe Test 50 or Safe Test 99 that will store the data. So I can definitely get that over to you.
Okay, that's great. Does it matter where the safety analyzer is plugged in, i.e. red hospital receptacles?
It shouldn't, no.
What about RPT testing? What are the guidelines?
RPT testing, I am not familiar with RPT testing, but I will look into it. RPT.
Okay. Yeah, I will definitely send you all these afterwards, Brittany, so you can contact the attendees directly.
Okay, great.
Okay, no problem. Another attendee is asking, I haven't heard of reference to reverse polarity testing. Is that something that's no longer being done?
Yes, so
Polarity.
yeah, reverse polarity. Yes, we don't do that anymore in the States. The reason why it is displayed on our safe test is because it is still done internationally, and we're based out of the UK. That's where everything is manufactured. So really, you can just completely ignore that button on our machine because the states don't do it anymore.
I also had a request. Where can we find the video you weren't able to show?
Actually, I can email it to you, but better yet, if you just go to YouTube, you can type in Safe Test 50, and there's a couple of them. I actually just recorded one testing a bed in a facility. So if you email me and let me know you would like that, I can send you a link to it. And there's also a bunch of testing on the Safe Test 99 that's on YouTube as well, which is identical to the 50, except that it can also do applied parts, but it operates completely the same as the 50. So those are all available on YouTube, and I believe there should be at least a couple linked on our website as well.
Okay, that's great. Do we need to follow NFPA 99 2018 if it has not been adopted by CMS or JC? We still have to follow 2012 since it's the last one they adopted.
That is correct, and I know they're few and far between, but I do have a handful of facilities that are required to follow the 2012. So that would just be something to check with your supervisor about.
Okay, we've had quite a few coming in. I'm just working my way through them for you. Okay, here's another one. Are the new standards looking for test devices that will download data from the analyzers so they can be attached to work orders for documentation?
As of now, they are not requiring it. And that's where that sheet that I showed you would come into play. We just send that to them. And it's just simply a pass or fail. Pass or fail determined by you guys or by the biomed. It's not required. Could it in the future? Possibly.
Let's see what else we have. How do you measure fixed equipment leakage currents?
Oh, so this is kind of another gray area. I found that probably the easiest, but then again, all hospitals have different regulations, is an extension cord. That's the only option that I've seen actually work. Yeah, and I actually have some information on that I can I'll send out as well. But yeah, that's where it kind of becomes a gray area. And then once again, every hospital is completely different when it comes to fixed equipment and being in the OR and all of that stuff.
Okay. Does the NFP 99 and 62353 cover extra requirements regarding ECG equipment?
I'm sorry, do they require what requirements?
Where are we? Give me a second. ECG, regarding ECG equipment.
Yes, and I went over that in the presentation. That's where it gets easier for you guys in terms of applied parts like your ECG. Now you can tie them all together and test them as one. So those two guidelines make you guys' life a whole lot easier.
Okay. Another one is, how do you test for millivolts?
Millivolts. I'm not sure if our safe test does that. Let me look into that one then. Because we have our four analyzers are completely different. So I'm sure we would have one that would do it. And I know you couldn't see in the video, but it does break down voltages at the very end. And it'll show you your hot to neutral, hot to ground, neutral to ground, and breaks that up in by volts. But you can see those on the videos if you would like to check it out.
Okay. What is your definition of fixed equipment?
So fixed equipment is basically anything that is hardwired directly into the facility. So 9 times out of 10, that is in the OR.
Okay, that's great. Time for a couple more. How do you do electrical safety testing inside a room with line isolation monitor?
Oh, that's a tough one. I'm pretty sure it would, line isolation. I'm pretty sure it would have to be done similar to the fixed equipment, but let me get a more detailed answer on that for you.
Okay, right. Let me see. We have time for about one more question. Let's see. What is the right term of leakage current? I've heard that touch current is the new term of leakage current.
Yeah, that's true. And I don't really have an answer for that. I hear it called both, and equally about 50-50. So I guess whatever you're more comfortable with. I'm not sure that either one is right or wrong, but most people know what you're talking about if you use either term.
Okay, right. Time for one more. Does AMI have a standard with reference to insulated equipment that concurs with NFPA 99?
Ooh, so the AMI standards, I'm not super familiar with. I haven't heard of anything as, you know, we test everything to the 60601. But I know that it is very similar and was derived from 60601. So I would think that there would be, but I can dig into that one too, because it's pretty similar. The two are pretty similar.
Okay, that's great. Well, I will be sending all the questions to Brittany so she can answer them offline or expand. So please be patient for her to respond. So thank you, Brittany, for a great and very informative webinar. And obviously, thank you again to today's sponsors, Rigel Medical. We appreciate that. Just a quick reminder that we have now automated the post-webinar survey and certificate process, and hoping that you're finding it more convenient. The survey link will be included in the follow-up email, which you'll receive in about an hour's time. Once you've completed the survey, you'll be able to download your certificate immediately. So one lucky attendee will still win an Amazon gift card for completing the survey. If you have any questions, please contact us at webinar@mdpublishing.com. For more information about our upcoming webinars, please visit our website, webinarwednesday.live. So thank you all again for joining us today. Hope you enjoy the rest of your day and hope to see you next week.